Well, hello friends. Today we are gonna continue doing even more stuff in the process manager. Today I'd like to add some file system information to it so that you can see like the different stuff that you would normally look up in like df or something like that, or mount, but we don't really have a mount command that dumps stuff, but this information basically, and maybe some more interesting information that we could come up with. I would like to show it here in like a separate tab that we could call file systems, I guess. So let's try doing that. Hopefully we can benefit from some of the stuff I've been doing in the last couple of videos to make this easier for ourselves. So we'll see how all that works out now. Let's see. So first thing we're going to do is just go straight to Process Manager main, and we're going to make a new tab. I guess here. So after network, although we'll put this one first. Like I like to do that just when we are developing something here. So we'll say like file systems. I'll just go FS widget, maybe. Just be a simple G widget. File systems, and in this thing we will just put, I think, at least just to begin with, we can just put a simple table. So new G table view, FS widget, and then let's see if we can pull in a JSON model right here. So I'm going to use this JSON array model. Now I've been working on that a little bit since the last video, so it has a little bit more functionality than what you've seen if you were following this, but not terribly much. It's just a little trick that it can do. So let's see. I guess the first thing we should do is take a look at that JSON just to see what we're working with here. And you crashed on startup, but why? I don't know why, but let's just do a restart here. Okay, so jp proc df. Oh wow, it's a little. Okay. So let's see. So for each file system, it's an array, and for each file system we have this information here. So then what we'll do is we will do a vector of gjson array model field spec, and we'll call it like df fields. And then we will add to this. I think I have to check the constructors. Yeah, so this is these are the two ways you can create a field spec. Either you say the JSON field name, so like this name here, and the column name that it should have in the model, and then what kind of text alignment it should have. Or you can also specify just a column name for the model, the text alignment, and then a callback function that gets called with the whole object, and then you can generate any data you want from whatever's in the object. That's the new feature that I was adding yesterday after I finished recording. Anyway, so here let's just use what's in the JSON model. So mount point, we'll call it mount point, I guess, and it will be text alignment left, center left. Oopsie doopsie. And I guess what kind of thing it is. So class name, let's call it class. And we don't have the block size here, for instance, so I can tell already that we're gonna need to add that. So let's add that right away. Point. Okay, so here is procfsdf. This is the function that generates this JSON. So we will just do fs object set block size. I think it would really be that easy, I think. How about you die and start over? No? Oh, right, yeah, because I didn't finish editing this part here. 43. What did I forget? Forgot to save. Table view set model on JSON array model create proc df and move df fields. I suspect that this would be enough just to get us started with testing. But let's add something more interesting here. We can also add like the block count. Total blocks. And free inode count and total inode count. Okay. Now, block size was the one thing I forgot to put in there. So. But we didn't build, so that's okay. Block size. Why did we fail? procfs. I guess maybe there's no such thing as block size. Class fs has no block size. Is that so? Block size. Where the hell did we get the block size from? Fs block size. Oh, it's if it's a disk-backed fs. Then we have block size. I feel like all file systems should have a block size. It's weird that they don't. So let's move this puppy up to fs, because I think it's just something that all file systems should have. Turn in block size and okay, so we'll have to move this guy here, and this integer will now go here. And stop doing that. Okay. Now this function is going to need to move to fs file system cpp. Where are you? Oh, did I make it in time? I don't think I did. No. Okay. Oh, did we get that frickin' stack alignment bug again? Well, can't debug that right now. Okay, so we definitely have a tab, but there's no information in it, so not a huge success. Let's see what we forgot. At some point, I'm probably gonna have to rename Process Manager to like System Monitor or something like that. The FS table view is in that widget, but that widget doesn't have a layout, so that means that if you just add, I'm just adding this table view to be a child of the FS widget, but the FS widget doesn't automatically resize its children, so nothing will happen. So we have to set some layout. It's just a filling layout, like a box layout is what I usually use. So, oops, make all and run. Okay, well, at least now we can see this here, but we're not getting any data. So I guess we have to actually call update on this thing. Model update. That's a bit silly, but I mean, I understand why it turns out like that, but because the model is not going to automatically update until you tell it to. I don't know, maybe it should, like when you're when you're setting a model in a view, but at the same time, you don't necessarily want the model to update then, because what if update means that like you do networking or something? Probably you would want to control that yourself. Wow, we're just falling apart in this thing. I wish this stack alignment thing would happen when I'm not recording. So I could take a look. It's silly. Okay, come on now. Here we go. Right, so now these are all like 100 wide, and we definitely want to use auto sizing for this because they're all too wide. So let's turn on the auto sizing that I made a couple videos ago. So FS table view, set size columns to fit content true. And I think basically this here should be everything that we need to add this functionality. Contrast that to what I would have had to do like a couple of days ago, which would be to like create a new class, a model subclass, and then fetch all the JSON manually, parse out the different fields and convert them and so on. So this is definitely a huge productivity improvement. And I don't have to like figure out what the sizes for the columns should be either, because we can just auto size them like we do now. It's really nifty. Kind of jealous, like you notice how these things have this little margin here, but this thing doesn't. Terrible. So let's use this 4 margins on the FS widget. So very important detail. But maybe we could show some more interesting information in this table, by the way. Let's just see that it looks nice with the margin. See, now the margin is all neat. Beautiful, isn't it? Okay, so that's kind of cool that you can see the different block sizes. So how about we compute the space in bytes, for instance, instead? So like, or like, I don't know, the utilization. This, what do they call it in df.h? available and use percent size. Yeah, because like, I mean, this stuff is kind of interesting, but at the same time, it's not really, because you're more looking for probably the amount of bytes is what you're generally interested in. So maybe we should change this. Maybe we could have them say like blocks and inodes in a single column. Anyways, let's see. Let's do the used used and available size and used. Yeah, okay, let's do those. So here comes that new feature that I was talking about. So what you would do here is you don't specify a JSON field because the size isn't in any one JSON field. It's like we're gonna have to do a computation. So what you do instead is you just specify the column name that you want, and then the text alignment, center right, because it's gonna be a number, and then what you get here is a const JSON object. And then here, we just return whatever we want that field to contain, or that column to contain for this row, based on what's in the object. So that would be, in this case, the size of it, I guess, is the total block count times the block size. So that's object.get total block count to U32 times object.get block size to U32. Boom. And then I guess we can also do used, and what do they call it? Avail. So used would be, I guess it's like this one. We'll do like total blocks, and the other one was free blocks. So free block count. Used blocks is total blocks minus free blocks. Like that. I'm kind of spelling it out to make it obvious, but you get what I mean, right? And for available, it would be that's just the free block count. So like this. And then yeah, so the way it works is that this callback here is invoked whenever we are trying to show the data of one of these table cells. Then we invoke the callback, and it tells us what to show. So this is what you get. Kind of cool. These are a little clunky though. Maybe maybe we should have some kind of pretty printing thing. Size. Let's see. Human size. We'll make a little helper for this. So human readable size. Okay, and then we'll just put that here. Human readable size. Let's see, so if it's less than, where do we do the cutoff? If it's less than 4K, then return string. I'll just say maybe like that. And if it's less than 1 meg, then do kb. Size divided by kilobytes, and then whatever gigabyte is, then we'll just do in megabytes. And otherwise, I guess just return string format. So if it's like greater than a gigabyte, then it's a terabyte, and we'll say how many gigs there are. I don't know the gigabyte one by heart. Maybe I have constants for these actually. I do. Oh shit, that's cool. Should have one for terabytes as well. Then we can instead do like size divided by kilobytes divided by megabytes divided by gigabytes. Yeah, that one is always going to be true, right? Or rather, result of comparison is always false. Okay, well, this is stupid. I guess we'll just do this. Yeah. That's fine. I feel like there's some natural cutoff point. Maybe it's like 128 kilobytes or something like that. I'm not sure exactly where the cutoff is. I said 64. And like that. Okay, that's enough screwing around. Let's just try it out. That terabyte thing, I'm not super happy with that, but I guess it's okay. What does that look like anyway? It's a big number. Wonder what you get if you Google for that. Gonna make the video lag here by launching Firefox. The proxy server is refusing connections. The hell did I set up a proxy for? I don't remember doing that. I mean, I do remember doing that, but I don't remember why. No proxy. Okay. We're on an important mission here to Google this number. Nothing fascinating. All right. Hurry up now. And TD terabyte constant. This might be useful at some point. Data type should probably change. Yeah, like it doesn't even make any sense. Like, why am I putting a wait? See, I'm doing something screwed up here, right? Like I'm putting a terabyte into a unsigned. It's not going to fit. So why am I sitting here doing this? This is stupid. Let's undo this because we are just it's the thing that you do. Head -1. That's just a bad idea. I'm gonna have to do that correctly when the time comes. Anyways, rebuilding is fast now because we're not touching ACK. So forget that whole thing. Don't try to store a terabyte number in a 32-bit int because, you know. All right. Now these are some numbers that I can get behind. Although the B here looks kind of dumb. So maybe that should just be empty. But other than that, it's pretty cool. I like it. Very nifty. So that's really awesome. I wonder if there's something else interesting on a file system that we could show. Show whether or not it's read-only. That's interesting. I mean, all of these are going to be read-write, but we can still surface it in the UI. So let's see. Maybe we'll call it like writable or read-only. We'll call it read-only here. FS is read-only. In process manager main, we can just add a column for that. Where do we put it? Maybe after available. So here, say read-only. Maybe we call this access. Maybe we make a custom one for this actually. So be left aligned and return object get read-only tuple. And we'll say writable read write. Otherwise, read only. Oh, we have one already. Okay, so maybe I've had enough fun with this and we should just commit and let it go. But the last thing we're going to do is we're going to make it so that it's not the primary tab when you open the process manager, because we still want that to be the process list. As much as I enjoy making these new little tables. Read only. Oh, but that's not right. Why does it say that? Oh, right, because I confused everything. It's like that. And then we'll also move the tab. So file systems, let's just do this at the very end instead. This main function here is getting really messy. This doesn't make any sense. But I don't like changing unrelated things, so I'm not going to touch that here. So let's see, maybe we'll put this in a function. And where's the last tab that we're adding? Processes. So here we can just say, instead of this code, let's see, tab widget, add widget. Or, no, let's just do it this way for now. Or do we have to? This is messy. This is messy. Okay, okay. Tab widget, add widget, file systems. Build file systems tab. This can be a static G widget. Build file systems. There we go. Table view. no, we return fs, what was it called, fs widget, right. Makes this a little easier to understand this if we don't keep growing. I should really like move this function around and make it a bit more readable, because we're adding so many tabs now that this is just becoming a mess. So I think this is the way forward, to separate it out into functions. So yeah, this is the file systems tab. And it should be the 4th tab this time. It's the 2nd one. Because why? Because because it's still here. Because I'm silly. Okay, it goes after the network. Does it go after the network? Maybe it goes after the graphs. The details now are getting really important. There's going to be so much user interface polish to do one day when everything else feels good. But for the time being, we're just kind of throwing things together and trying to keep it kind of clean as we go. I mean, I think it's still like looking pretty decent for like programmer art. But it's something that I would certainly like to improve in time, make things look better. But yeah, this is not bad, I would say, but of course I have bias. Yeah, so I think this is pretty cool. I got to show off the new computed field feature and just make use of the JSON model that I made last time. So let's see what we have. What do we have here in the file system? Oops, file systems. So let's do the moving the block size to the FS class. Why am I typing the same thing twice? So that's just moving block size, right? So file system move block size from disk back to file system to FS. Let's just say that all file systems have a block size to keep things nice and simple. And then we also had procfs. We're just adding these two fields here. So, oops. Why is typing hard? Readonly and block size to proc df. And then all that remains is the file system tab. Pretty cool. Pretty cool. Did everything look logical here? You've used this much is available, and this is what it adds up to. With some rounding missing, but general numbers look sound. Cool, very cool. Okay. Process manager and a file systems. How about mounted FSs? Readonly info about trying to fit it in 72 characters. Beautiful. So this was rather nice and easy to add with the new JSON array model. Boom. Cool. That is pretty cool. So I think this is going to be it for today's video. So I hope you saw something interesting here, and I would like to say thank you for watching, for hanging out, coming by, and for bearing with me as I keep adding stuff to the process manager as it grows and grows and grows. It's pretty fun. And this is like, it is a really fun part of making an operating system. It's like when you get to this point where you can start exposing kernel things in user space and coming up with like, what can we show? Because controlling the whole stack, you can show anything, right? So if you have some ideas for what we could show, then comments below, please. Because that's sky's the limit. So yeah, thanks for hanging out. And I'll see you next time. Bye.